Section 7.3, Introduction. Pretty soon we're going to be adding and subtracting rational expressions, which means fractions that have variables in them. And we're going to use the same rules that you do if you have just numbers. For example, if we were going to add 1/9 and 1/6, we would first find common denominators. So for 6 and 9, a common denominator would be 18. So we would want to rewrite the fractions with 18 as the denominator. So I'll put over here the LCD, or the least common denominator, is 18. And we would multiply each fraction by what we need to make it turn into an 18 in the denominator. And then the top gets the exact same factor. So I get 2 over 18. 6, to turn 6 into 18, I need to do times 3, top and bottom. 3 over 18. And then I would go ahead and add the tops and keep the denominator. So we're going to use those same steps, but we're going to break it down. So section 7.3 is a bit of a transition. 7.3, we're going to learn how to, first of all, find the LCD if you're given some algebraic fractions. And we're also going to learn how to do the rewrite step, which we did up here. Rewrite fractions. And then in 7.4, we'll actually do the adding and subtracting fractions. Oops. Subtract. There we go. All right, so let's look at, first of all, finding the LCD. So 7.3, number 1. If I want to find the least common denominator for 9, 6, and 2, well, for 9 and 6 it would be 18, and 18 works for 2 also. So the LCD, by inspection, is going to be 18. And remember, least common denominator is the smallest denominator you can turn each denominator into by multiplication. I'm going to show you another way to do it that we're going to need to do when we have variables in there. So to find the LCD, you're going to use a couple of steps. First, you're going to factor the denominators. So for the problem we have here, the factor denominators would be 9 is 3 times 3, 6 is 3 times 2, and 2 is just 2. All right, so we'd have 3 times 3, 3 times 2, and 2. Then you use those factors to build the LCD. And the way I usually do it, there's a bunch of different methods, but I find this way works pretty well, is take the entire first denominator, 3 times 3. And we're going to multiply onto that. Anything in the second denominator that's not already contained here. 3 is already there, we don't need it, so we need 2. And then we'll multiply onto that anything from any other denominator that's not contained there. 2 is already there, so we don't need it. That means we're done. And we get 3 times 3 is 9, times 2 is 18. So that's how you build an LCD. And just notice when you're done building it that the LCD should contain every denominator completely without having any extra pieces that we don't need. So 3 times 3 would be right there. 3 times 2 is right there. And just the 2 is right there. So everything's contained. Okay, so that was number 1. Let's look at another one. 7.3, number 4. And we're always going to use the same steps. Factor, build. So the factor step, 35 is 5 times 7, and then z to the 8 is just z to the 8. And then 175, well, we can factor that by using the tree method right over here. So if I divide that out, let's see, divide by prime numbers if you're not sure where to start. Let's divide by 5. So 5 times 35 would be 175. Then keep going with the 35 because it could still be broken down. 5 times 7. And that means 5 times 5 times 7 would be the factored form of 175, and then z to the 5th. And now we build. The LCD equals take every piece or every factor of the first denominator. 5 times 7 times z to the 8. Now look at the second one and see what's missing. Well, we've got one 5, but we need another 5. There should be 2 5s there. We've got the 7. We already have z to the 5th contained in z to the 8th, so we're not going to put another z to the 5th in there. So our answer for the LCD would be 5 times 7 is 35 times 5 is 175, z to the 8. And number 7, find the LCD again. First we're going to factor 5 times x plus 5 and 2 times x plus 5. And then we're going to build. So factor. So our LCD will equal, take the entire first denominator, 5 times x plus 5. And now we put in any missing factors from the second one. We've already got x plus 5, and this entire x plus 5 in parentheses is one factor. All right, so we're never going to take just the x or the 5 separately. Take the whole thing. And the only piece missing is the 2. So that means our LCD is 10 times x plus 5. And number 9, find the LCD. Same steps. First we factor. K times k plus 7. And this one is trinomial, so we're going to get a binomial factoring. 4 times 7 will give us 28, so we have k, k. We want the 7 positive, so we get a plus 3 middle term and the 4 negative. And now we build the LCD by taking the entire first denominator, k times k plus 7. And now we're going to multiply in anything that's missing. K plus 7 is already there. K minus 4 is not. So we need to multiply that in, and there we have it.